Okay, my name is Dave Andrews, and what you're seeing here is a gasoline engine that was developed for airplanes in the 60s. Now, this little back arm here rotates back and forth, and up here on the top is where the air comes in. Now, on the other side is where the gas comes in, and it comes in as a liquid and then goes into the carburetor here. In the carburetor here is where the oxygen, the air or the oxygen is coming in. So by turning this little arm here back and forth, we can vary the amount of oxygen coming into the engine. So when we designed this engine, the people in electric had to here we put a rod and make a servo, and I'll show you that in a minute. But essentially, when this what is proportional, what it means when it's idling, and then as we move it in one direction, the propeller starts to speed up, or here in the helicopter the blades start to turn to full speed. So that's proportional. So we can set the speed of the propeller or the helicopter blades. They vary. Okay, so I'm going to show you a servo in just a minute. Okay, on the right here, this is the servo. Inside is the motor and the electronics. There's a wire that comes out of this too. Now, this white head here turns back and forth. Now, if I was connecting up to that gasoline engine, I'd have to turn it on the side and connect a rod here. Now, these are just different servo arms. I don't know what they are because I've never used them, but just depending how you connect anything. So I'll show you one in just a minute. Now, in this picture, you see the servo there. There's the servo arm, and there's the tie rod, what's called the tie rod, that connects the thing. So this, when you move a stick, this moves back and forth to control whatever you're controlling. And okay, so I'll show you an airplane and why you need 4 channels. But essentially, 1 channel per servo. That's basically how they developed it in the 70s. Okay. Okay, in a plane we have 4 channels, or 4 servos. One for the propeller. Then on here are metal flaps for turning, which are the ailerons. Now here we have a rudder, which is mounted vertically. Now I haven't got the piece here, but it's the elevator, which is horizontal, and they can all vary, so they're proportional. Now when you have the 5th channel, when you take off, you throw a switch and the landing gear comes up, and then when you go to land, you throw it the other way and it comes down, but it's not proportional. It's just sort of like up or down. Now, somebody asked us about the Lifehawk, and Lifehawk said it turns this one on. So yes, it is a variable? Who knows? And sometimes I think with these helicopters, they look like they're moving, but they take a little time to get up to speed. So if this, I would call this, a 2.5 channels. And then when you go to a 4 channel, it's the same thing. It moves left and right, but it has a tendency to drop. So it's not really like an airplane. And then the other thing is the 5th channel. What it does on a gasoline is it varies the pitch of the blade as you go to hover. It makes it easier to fly, to stay stable. So that's the basic what channels are. And I guess with helicopters, we really should come up with another name. And that's how airplanes develop. But in the 50s, when they flew them, say this is a real and it goes to 20,000 feet, he said that what they do is start it and then it would go up, and they used the rudder to go left just to turn it, and then what they did, they turned up the wings to make it easier. So that would be like one channel, one function, and then when it ran out of gas, they landed it. But they don't use those. That's what the source of Radio Shack called full function. It's just one speed forward, one speed backwards, and the wheels go left or right. So that's a little bit how channels developed, and it'd be best just not to call them anything. Okay, happy flying.